One bridge spirals like a roller coaster, another stretches higher than the Eiffel Tower, and in the Arctic, engineers built one that survives avalanches, darkness, and hurricane-force winds every single day. These aren't sci-fi movie sets, they're real, and they're pushing the limits of what bridges, and the people who build them, can actually do. In this video, we're breaking down the most insane bridges on Earth and explaining what makes them possible. From underwater megastructures to mountaintop skywalks, these are the bridges that shouldn't exist, but somehow do. And one of them just broke 10 world records. Let's start with the Millau Viaduct in southern France, the tallest bridge in the world by structural height. Before this bridge existed, anyone driving from Paris to Spain had to wind their way through the Tarn Valley near the town of Millau. The descent was steep, the roads narrow, and the traffic brutal, especially in summer. Drivers faced a 19-kilometer detour that could turn a smooth highway trip into a crawl. By the late 1990s, France had a decision to make. In 2001, construction began on a bold solution, a bridge straight across the valley. Designed by architect Norman Foster and engineer Michel Verlegueur, the Millau Viaduct stretches 2,460 meters, nearly 2.5 kilometers long. At its highest point, the structure rises 343 meters from the valley floor, taller than the Eiffel Tower. It opened in late 2004 after just over 3 years of construction and a budget of €394 million. What's remarkable isn't just the height, it's how the bridge behaves. It was engineered to flex and breathe. On hot days, it expands. On cold days, it contracts. In total, the deck can shift by up to 2 meters, and in strong winds, it sways just slightly and exactly as designed. The views from the bridge are so stunning that they create an unexpected problem. Drivers kept stopping in the middle to take photos. So officials had to lower the speed limit to keep traffic moving safely. Today, the Millau Viaduct carries around 10,000 vehicles a day and stands as one of the most iconic engineering achievements in Europe. Now we head to Japan's Izu Peninsula, home to one of the strangest bridges in the world, the Kawazu Nanadaru Loop Bridge. In 1978, the region was hit by the Izu Oshima earthquake, a magnitude 7 tremor that triggered landslides and destroyed parts of a crucial mountain road, National Route 414. Entire communities were suddenly cut off. Rebuilding the usual way wasn't an option. The terrain was far too steep and narrow for standard switchback roads. So engineers did something unusual. Instead of zigzagging up the mountain, they decided to spiral around it. By 1981, Japan had built a double helix loop bridge, a giant concrete spiral that looks more like a roller coaster than a road. It climbs 45 meters in elevation by looping twice in a full 720-degree circle. Drivers complete 2 full loops, one on the way up, one on the way down, to safely gain altitude without steep inclines. The entire structure stretches 1,064 meters in length, with a consistent 40-meter radius and a single 2-lane deck shared by both directions of traffic. But building it was only half the challenge. The real test was public trust. A twisting elevated roadway can feel unsettling, especially after an earthquake. So engineers prioritized safety. They imposed a strict 40-kilometer speed limit, banned overtaking, and designed the curves to be gentle and predictable. Even cyclists can ride the bridge thanks to its extra wide lanes. Today, it's both a vital transport link and an engineering icon in its own right. Still in Japan, the next bridge is Akashi Strait, where engineers built a bridge so massive and resilient it quite literally moved during an earthquake and survived. For decades, the only way to cross from Kobe to Awaji Island was by ferry. But ferries had problems, especially during typhoons. In 1955, a disaster known as the Shion Maru tragedy killed 168 people when 2 ferries collided in dense fog. That incident sparked public demand for a safer, more permanent crossing. By the late 1980s, Japan had committed to building the world's longest suspension bridge. a structure that could endure typhoons, strong ocean currents, and even earthquakes. Construction began in 1988, but in 1995, just as the towers were nearly complete, disaster struck. The Great Hanshin earthquake, also known as the Kobe earthquake, hit the region with devastating force. And here's the astonishing part. The two bridge towers moved 1 full meter further apart. Most projects would have been scrapped, but instead of starting over, the engineers simply adjusted the design, adding an extra meter to the central span. Problem solved. By 1998, the Akashi Kaikyo Bridge officially opened. Its central span stretches 1,991 meters, making it the longest suspension bridge span on Earth. The total length? Just under 4 kilometers. Its two towers rise 283 meters above sea level, and the foundations plunge nearly 60 meters below the water's surface. This bridge isn't just big, it's built for survival. It can handle winds up to 286 kilometers per hour and earthquakes up to magnitude 8.5. Each main cable is over a meter wide, patched with 36,830 individual wires, totaling more than 300,000 kilometers of steel. That's enough to circle the Earth almost 8 times. The deck itself uses a truss-stiffened design that flexes with wind, not against it. And underneath, massive steel caissons anchor the structure deep into the seabed. The bridge cost about 500 billion yen, or roughly 3.6 to 4.3 billion US dollars at the time, and took a full decade to complete. But the impact was enormous. For the first time, Awaji Island had a fast, permanent link to Honshu, and the Akashi Kaikyo Bridge became a global icon of engineering resilience. It held the world record for the longest suspension span for over 20 years, and still ranks among the most advanced bridges ever built. Japan may have held the record for the longest suspension bridge for over 2 decades, but when it comes to height, as in how far a bridge deck hangs above the ground, China is rewriting the rules. In the mountains of Guizhou province, engineers have just completed the Huajiang Grand Canyon Bridge, a structure so high it floats more than 2,000 feet above the riverbed, making it the tallest bridge on Earth by deck height. At its peak, the bridge deck floats 950 feet taller than France's Millau Viaduct. The North Tower stands 262 meters tall, and the main span stretches 1,420 meters across, supported by a web of 22,000 tons of steel, roughly the weight of 3 Eiffel Towers. But building at this altitude came with serious challenges. Wind gusts that shift by the second, extreme temperature swings, zero margin for error. Engineers used satellite-guided systems and the largest cable crane in the world to lift and place 93 modular steel sections, each one weighing tons, with millimeter-level precision. They also incorporated real-time stress and vibration sensors to monitor the bridge during and after construction. The design is as aerodynamic as it is efficient. Hollow steel trusses reduce wind resistance, and the structure is engineered to flex, not fight under pressure from wind and seismic activity. And this isn't just a road. The Huajiang Grand Canyon Bridge is also a destination, featuring an 800-meter glass skywalk inside the truss, a glass elevator to the top of the South Tower, a tourist center with architecture inspired by Zaha Hadid, and the world's highest bungee jump, launching from a platform more than 2,000 feet above the river. What used to be a 70-minute ordeal now takes under 2 minutes, and with a price tag of just 1.87 billion yen, about 280 million US dollars. Nearly half of the world's tallest bridges are now located in Guizhou, making this once remote region the bridge-building capital of the world. Japan held the record for the world's longest suspension bridge for over 2 decades, but in 2022 that title passed to Turkey. The 1915 Çanakkale Bridge didn't just break records, it connected 2 continents with a span longer than anything ever built. For centuries, the Dardanelles Strait has separated Europe from Asia. Crossing it meant taking a slow, weather-dependent ferry, or driving hundreds of kilometers around the Sea of Marmara. Neither option was efficient, and for Turkey, a country that sits at the crossroads of global trade, that wasn't good enough. So in 2022, Turkey completed something historic: the 1915 Çanakkale Bridge, now the longest suspension bridge in the world. The numbers are staggering. A main span of 2,023 meters, symbolically marking the 100th anniversary of the Turkish Republic. A total length of 4,608 meters, including approach viaducts. 318-meter towers, among the tallest ever built for a suspension bridge. 70 meters of clearance for the world's largest cargo ships. The project cost an estimated €2.5 billion, around $2.8 billion, making it one of the most expensive infrastructure investments in Turkey's history. But the return on that investment is already paying off. It forms the centerpiece of a 321-kilometer motorway, dramatically reducing travel times and saving hundreds of millions of euros each year in fuel, logistics, and delays. Built to endure typhoons, earthquakes, and 288-kilometer-per-hour winds, it's as resilient as it is symbolic. And perhaps most impressively, this is the first bridge in history to span over 2 kilometers in a single suspension span. Now let's talk about the highest railway bridge in the world. For decades, India's Kashmir Valley was cut off from the national rail network. The Himalayas made it nearly impossible. Roads were narrow and dangerous. Winters brought avalanches. Landslides were common. And building a rail line across this terrain wasn't just about convenience. It was about unlocking opportunity, trade, and long-term stability. The biggest obstacle? The Chenab River Gorge, a deep canyon surrounded by jagged cliffs and high seismic risk. So, in one of the most ambitious rail projects ever attempted, engineers began constructing a steel arch bridge that would soar over the gorge. The project spanned nearly 2 decades, with the core archwork taking place between 2017 and 2022. Here's what makes this bridge extraordinary. The deck sits 359 meters above the river. That's 59 meters taller than the Eiffel Tower. The arch span stretches 467 meters, making it one of the longest of its kind in the world. The total bridge length is 1,315 meters, and it used 25,000 metric tons of steel designed to last over 120 years. To build it, workers used massive cable cranes suspended across the canyon, a global first at this scale. Each section was lowered and locked into place with millimeter-level precision, while enduring wind speeds up to 266 kilometers per hour, freezing temperatures, and the constant threat of magnitude 8 earthquakes. The bridge is protected with a corrosion-resistant paint system and seismic isolation technology built into its foundation. It cost around 14.86 billion rupees, roughly $180 million. But the real payoff is what it connects. For the first time in history, India's rail system will extend directly into Kashmir, cutting travel times, boosting tourism, and linking the region to markets and opportunities across the country. Next, we head to one of the boldest engineering projects China has ever attempted, a megastructure designed to stitch together 3 of the world's busiest cities. The Pearl River Delta in southern China is one of the most economically vital regions on the planet. But for decades, moving between Hong Kong, Zhuhai, and Macau was painfully inefficient. Travel meant slow ferries, clogged border crossings, and long detours around the delta. So China decided to build something radical: a 55-kilometer bridge tunnel system connecting all 3 cities directly across the sea. It's called the Hong Kong-Zhuhai-Macau Bridge, and it's unlike anything else on Earth. The system includes 3 cable-stayed bridges with spans ranging from 280 to 460 meters, a 6.7-kilometer undersea tunnel built to avoid disrupting the shipping lanes and Hong Kong airport flight paths, and 4 artificial islands, 2 as landfall points and 2 as connection hubs between the bridge and tunnel segments. The project took 9 years to build, starting in 2009 and opening in 2018. It cost roughly $18.8 billion and was engineered to last 120 years while withstanding magnitude 8 earthquakes and super typhoons. And it worked. The bridge reduced cross-border travel time from roughly 3 hours to as little as 30 to 45 minutes by car, unlocking faster trade, tourism and logistics between Hong Kong and mainland China. The scale is staggering. Over 400,000 tons of steel, more than 1 million cubic meters of concrete, enough material to build 60 Eiffel Towers. Even the tunnel, an immersed tube laid beneath the sea, ranks among the longest in the world. Across one of the busiest shipping zones on Earth, China just pulled off another record-breaking feat, this time beneath the sea. The Pearl River estuary is packed with cargo ships, unpredictable tides, and non-stop maritime traffic. So China built the Shenzhen-Zhongshan Link, a 49-kilometer megaproject combining bridges, tunnels, and artificial islands in one continuous system. It opened on June 30, 2024, after 7 years of construction. And this isn't just infrastructure, it's a masterclass in marine engineering. Here's what they built. A 6.8-kilometer immersed tube tunnel, the longest sea-based road tunnel in the world. The Lingdinyang Bridge, a 1,666-meter suspension span, the largest of its kind ever built fully offshore. 2 artificial islands, each housing transition points between tunnel and bridge. And the highest deck clearance in China, 91 meters above the waterline, enough to let the world's largest container ships pass underneath. This link broke 10 world records, from construction speed to anchor size. One of them, the largest concrete anchor ever poured offshore, 344,000 cubic meters of reinforced concrete. Another, a patented M-shaped water stop, developed to seal tunnel joints underwater, a breakthrough that could reshape how tunnels are built globally. To make it work, engineers used over 1.2 million tons of steel, more than 3 million cubic meters of concrete, and 32 tunnel segments, each 80,000 tons, precisely sunk and connected beneath the estuary floor. The entire project cost about $4.83 billion, but it slashed travel time between Shenzhen and Zhongshan from 2 hours down to just 30 minutes. Now we head deep into the Arctic, to a bridge built in one of the harshest places on Earth. Just north of Narvik, above the Arctic Circle, the Hålogaland Bridge spans a fjord where avalanches, sub-zero winds, and total winter darkness are the norm. For years, the only road around Rombaksfjorden was narrow, winding, and often buried under snow. Whole communities were cut off for days at a time. So Norway did what it does best. It engineered a solution through the storm. Construction began in 2013, and by the end of 2018, they had completed the longest bridge ever built above the Arctic Circle, a suspension bridge stretching 1,533 meters with a main span of 1,145 meters. Its towers rise 179 meters from the rocky coastline, shaped like an A, a subtle nod to the surrounding mountains. Those towers anchor steel cables strong enough to resist hurricane-force winds and freezing rain, all while enduring months of polar night. But this wasn't just about crossing a fjord. The bridge removed a 17-kilometer detour, replacing one of the region's most dangerous roads with a year-round, storm-resilient corridor. And at 2.2 billion Norwegian kroner, roughly $250 million, it was a massive investment in northern Norway's infrastructure and accessibility. To make it work, engineers had to battle extreme cold and rapidly changing weather, limited daylight in winter, and complex foundation work in frozen terrain. The Hålogaland Bridge is now the second longest suspension bridge in Norway, and a symbol of how engineering can tame even the Arctic. It won international acclaim, including the Outstanding Structure Award from IABSE, and today it doesn't just carry traffic, it brings tourists, connects isolated towns, and proves even above the Arctic Circle, modern infrastructure can thrive. From record-breaking spans in Turkey, to bungee jumps 2,000 feet in the air in China, and Arctic cables fighting the storm in Norway, these bridges don't just connect places. Each one is a bet on technology, on geography, and on the future. So which one blew your mind the most? Tell us in the comments. And if you want more stories of impossible construction, extreme environments, and global megaprojects, subscribe to Megabuilds and share this video with someone who needs to see what's possible when engineers dream big. We'll meet you in the next one.